You ever wonder if we could create life from scratch? I mean, not just mimic it, but design entire new universes with their own unique inhabitants? Well, we are right on the edge of a new frontier in creation, one that's powered not by us, but by the imagination of AI. Let's get into it. See, before you can create life, you gotta ask a really big question. What even is life? What are the fundamental rules, the actual physics, that allow complexity and, intelligence to just emerge from simple stuff? It's a question people have been kicking around for centuries. And this question has never been more pressing. Just think about it. For our entire history, we've been the only game in town when it comes to advanced intelligence on this planet. But with these new AI foundation models, we could be watching a completely new kind of intelligence being born. The stakes are just incredibly high. So to get a handle on this, we need to dive into a field of science that's all about these huge questions. A field that's not just trying to understand life on Earth, but is actually trying to create totally alien forms of it. So welcome to the world of artificial life, or ALife for short. The goal here is just breathtakingly big. We're not talking about copying a bacteria or a bird, no way. This is about exploring the entire vast, undiscovered territory of all possible life, building virtual ecosystems and digital creatures from the simplest rules you can imagine. But there's always been this one giant bottleneck. To create life as it could be, you first have to come up with the fundamental rules for that universe. And how on earth do you find the right rules? The researchers put it perfectly with this analogy. Imagine trying to invent chemistry from the ground up. You don't know what protons or electrons are, you just have to guess how 100 different elements should interact with each other. The chances that you'd stumble on a set of rules that creates anything interesting at all, let alone complex, it's basically zero. Well, that's the exact problem ALife researchers have been banging their heads against for decades. Take the most famous one, Conway's Game of Life. You've probably seen those hypnotic patterns, the little blinking pixels and gliders that cruise across the screen. All that complex behavior comes from just a few rules that a human came up with. It's genius. But it was all intuition and manual trial and error. That's slow, and it's limited by our imagination. So what if the most interesting forms of life obey rules we could never even dream of? And this is where things get really cool. Researchers have found a way to use AI not just to live inside a world, but to be the one who actually builds the world. They call it ASAL, which stands for Automated Search for Artificial Life. The core idea is actually pretty simple, but it is so powerful. It uses a big foundation model, the kind of AI that makes images, as an automated observer. This AI can watch millions of little mini-universes, each with different rules, and its brain can figure out which of those rules lead to something interesting. So ASAL basically does three things. First, it can find a target. That's where you tell it what you're looking for, like a pattern that copies itself, and it hunts for the physics that makes it happen. Second, it can discover the new, where it just looks for worlds that are endlessly creative all on their own. And third, it can map everything, creating a kind of atlas of all the possibilities out there. Let's check out that find a target function, because this is just wild. In one experiment, the researchers gave ASAL nothing more than a simple two-word prompt. All it said was cell division. They didn't code how to do it, they just told it what they wanted to see. And the result was absolutely astonishing. ASAL just went to work, sifted through a bazillion different configurations, and it discovered the exact rules, the physics of this tiny universe that would allow a digital organism to grow and split in two. It reverse engineered a form of life, all by itself, just to follow that simple prompt. This is a massive leap forward. I mean, with something like Conway's Game of Life, the rules are fixed. The fun is just seeing what happens. But with ASAL, the AI is discovering totally new sets of rules that are way more open-ended and expressive, that can generate a kind of complexity we've just never seen before. So what has this AI world builder actually found? Well, the results are like stumbling into a digital Galapagos, a full-on Cambrian explosion of artificial life that nobody has ever seen before. For instance, ASAL discovered the rules that create this, Alenia orb. It's this dynamic, self-organizing pattern of pixels that moves and sustains itself, kind of like a tiny digital organism. And this is just one of countless new digital species it's found. It also works on group behavior.
Researchers took a classic simulation of flocking agents called boids and prompted ASAL to find rules that would create a Fibonacci spiral. And, well, ASAL found them. It generated this beautiful and incredibly complex flocking pattern automatically.
And it doesn't just stop at individual organisms or swarms. Using a simulation called Particle Life++, ASAL can discover the rules for entire ecosystems. It can find the physics that govern how different kinds of particles interact, creating these dynamic worlds full of competing and cooperating digital life forms.
And this all leads up to ASAL's third big job, mapping everything. This is the simulation atlas. ASAL generated thousands of different life forms and then used its AI to organize them all by how they look. What you're looking at is basically a field guide to alien life, a visual encyclopedia of all the possibilities inside this digital universe.
Okay, this is all visually amazing, but what does it mean for the big picture? What are the real implications of being able to automate the discovery of life and complexity? So why does all this matter? Well, first, by creating and studying all these different forms of artificial life, we can start to figure out the fundamental principles of complexity itself. Rules that might apply to life everywhere, not just on Earth. And second, those same principles, like self-organization and open-endedness, can be used to build the next generation of AI. We could move past our current models and create systems that are really, truly adaptive, creative, and can just keep learning forever.
As the researchers themselves say, this is a two-way street. AI can speed up the study of artificial life, and in turn, the lessons we learn from ALife can help us build more natural, more lifelike AI. It's an incredible feedback loop.
And that leads to this final, just mind-bending thought. If we can automate the search for a single behavior like cell division, what's stopping us from giving AI a much bigger set of prompts one day? Could we ask it to find the rules for a universe that starts with a digital primordial soup, then has a Cambrian explosion of diversity, and finally evolves into an artificial alien civilization? We don't know. But for the very first time, asking that question is no longer science fiction.